Number Systems 8, Working with Scientific Notation. Today's learning target, I can both add and subtract two numbers written in scientific notation. So in learning target 1, we learned how to write in scientific notation. In learning target 2, we're going to learn how to add and subtract. So we're going to describe in steps how to find the sum. And remember, sum is this idea of addition. So an addition problem here of two numbers in scientific notation. So first lesson, we looked at taking these really, really big numbers or these really, really small numbers and putting them into scientific notation. And one of the reasons why we do that, not only to be able to read it easier, but to also be able to add and subtract and multiply and divide more conveniently. So today we're going to work with addition first. So describe in steps how to find the sum of two numbers in scientific notation. So my first step is to check to see if your exponents are the same. This is a very important step because if your exponents aren't the same value, that means that you have to adjust your mantissa to make it the correct value. Because when you add, you have to have common exponents, kind of like fractions. When you add fractions, the bottom number, the denominators have to be common. When you add in scientific notation, the exponents have to be the same. To add to that, if not, so if they're not the same, adjust is your verb. Adjust the mantissa. Remember, mantissa is the number in front so that the exponents are the same. So again, if they're not the same, then you have to adjust. If they're same, you can move on to now step 2. So step 2 is you're going to rewrite the equations with the mantissas together multiplied by the multiple of 10. So you're going to rewrite the equation. So your addition problem, your sum, with the mantissas. Sorry about that. Together multiplied by the multiple of 10. So in other words, you're going to group together the two mantissas and put it in a parenthesis, and we'll look at that with examples here in a little bit. And then your multiplied by your multiple of 10. So remember that we looked in step 1 if the exponents were the same, so they should be the same. So if they're both 10 to the 11th, then you're going to put the two mantissas together with an addition sign between them, and then you're going to put times 10 to the 11th because that's the same. So they should be the same. Next step, this is the easiest one. Step 3 here, add the mantissas. So you have them together in the parenthesis. Now you're going to add them together to get 1. And the last and important step is that you are going to check, there's your verb, check and make sure the final answer, so after you add them and you made sure the exponents are the same, is written in correct scientific notation. And if it's not, adjust. So in other words, if the mantissa became, let's say you're adding 5 point something and 6 point something, and you add those two mantissas together, it'd be 11 point something. But in correct scientific notation, you can only have one digit in front of the decimal. So you'd have to move the decimal to the right one, which means then you'd have to adjust that exponent. Couple of reminders. If you move, and then we're talking about kind of the adjustment here. If you move, or in step 1, if you move the decimal to the left, you add to the exponent. So in that case, I was just doing 11 point something. You move it to be 1.1. For the mantissa to be 1.1, that means you're going to add 1 more to the exponent. If you move it 2 times, you'd add 2 to the exponent. And then when you move right, you're going to subtract from the exponent. So the first problem we're going to look at is 8 and 12 hundredths times 10 to the 7th. And we're going to add that to 6 and 13 hundredths times 10 to the 7th. So a couple things I want you to notice. The first thing that I do, my first step would be, is that I need to adjust my mantissa until both exponents are the same value. Well, in this case, we're going to look at both exponents here. I have a 7 and I have a 7, which means they're already in both the same value. So I don't have to adjust the mantissa. But if they weren't, my first verb, or my first step would be to adjust. The next thing we'd do, second step, is that we add the mantissas together. So we have 8.12, and we're going to add that to 6.13. So notice that it's just going to be addition here. So if I add 8.12 plus 6.13, I'm going to get the total, or the sum, of 14 and 25 hundredths. And then what you do is you just bring down the exponent and its base of 10. Since they're the same, you just bring those on down. I'm going to write it here first. So we add the mantissas, bring down the base of 10 with its exponent, bring that base of 10 down with its exponent, and we have, at this point, added the two together. Now my last step is, the verb is to make sure your answer is in the correct scientific notation. So if I look at this right now, my mantissa is not between 1 and 10. So I am going to have to move my decimal 1 over. So it becomes 1 and 425 thousandths. That mantissa is now in correct scientific notation. Now the deal is, though, when you move it to the right, which means I go 1 more place value, or I have to multiply it times 1 more 10, that means I'm going to add 1 to my exponent, which now makes my base of 10 to the 8th power. So my final answer is this last one here, 1 and 425 thousandths times 10 to the 8th. Let's look at example number 2. So I have 9 and 42 hundredths times 10 to the negative 5th. I'm going to add that to 7 and 32 hundredths times 10 to the negative 6. So step number 1, reminder, adjust is my verb, the mantissa until both exponents are the same value. Well, if I look at this, I have negative 5th and I have the negative 6, and those are not the same value. So I have to adjust one of these mantissas. In other words, change one of these mantissas so they're the same. I always go to the bigger one. So negative 5 is bigger than negative 6. So I'm going to adjust this mantissa to become 10 to the negative 5th, which means I'm going to have to multiply it times 10 to the negative first 1 less time, because I'm going bigger, which then means I'm going to move the decimal to the right. You've noticed I've done that twice now, moved it to the right, and I'm always adding 1 to the exponent when I'm moving to the right. So now I have 0.732. I'm still going to add that to 9 and 42 hundredths. And now I can actually add the mantissas because my exponents are the same. So we'll go ahead and add the mantissas. So 9 and 42 hundredths. We're going to add that to 732 thousandths. And remember, you just bring down your base of 10. So now it's to the 5th power. So when I add those together, I get 10 and 152 thousandths times 10 to the negative fifth. But notice that again, I got to look. My last step is always make sure your answer is in correct scientific notation. It is not, because this is more than 10. So I'm going to move it to the right 1. And that means I have to me, it makes sense that if I move it to the right, I have to multiply it times 10 one more time, which in this case is going to be adding 1. Notice I've done that 3 times now, added 1 when I moved it to the right. And so it becomes 1.0152 times 10 to the negative fourth. And that is my final answer. Okay, let's go through the steps now of difference. So it's kind of the same as addition. Of course, difference means a subtraction problem. So instead of adding the mantises together, we're going to subtract. So these steps should sound very familiar to before. So we're going to check to see if your exponents are the same. And as before, if they're not the same, because they have to be the same, you're going to adjust them. So if not, you got to stop and do a little work here. Adjust is your verb. So you're doing, adjust the mantissa. I'm sorry. So the exponents are the same. Step 2. So once you get your exponents the same, now you're going to rewrite the equation. This time in parentheses, you're going to put the mantisses with the subtraction. So rewrite the equation with the 2 mantisses together. Multiplied, so you're going to put your multiplication symbol there, by the multiple of 10. Third step, instead of adding, this time, of course, we're going to subtract the mantisses. So those 2 mantisses that you have in the parentheses, you're going to subtract them. And your last and final step, of course, the important part, is to make sure. So to check is your verb there. Check and make sure that your final answer is in scientific notation, correct scientific notation. If not, adjust as needed. Make sure the final answer is written in correct scientific notation. And then adjust if not. That's your other verb. Same reminder before, just go over it one more time here. If you have to move the decimal to the left in your mantissa, then you're going to add to your exponents. And if you're going to move it to the right, you're going to subtract. So now let's look at examples. So my first example is going to be 4 2/10 times 10 to the ninth. I'm going to subtract that from 3 8/10 times 10 to the ninth. Step number 1, the first thing I always look for is, do I need to adjust the mantisses so my exponents are the same value? So if I look, oh, they're both 9s. I don't have to adjust anything. I can now go ahead and subtract my mantisses. So I subtract my mantisses, and again, you just bring down that base of 10 with the exponents since the exponents are now the same. So it's going to be times 10 to the ninth. And so then I'm going to subtract. So 4 and 2 tenths minus 3 and 8 tenths makes 0 tenths. Or I'm sorry, 4 tenths times 10 to the 9th. So I subtracted my mantisas, got 4 tenths, brought down my base of 10 with that same exponent. My last step, the most important step, is to see if it's in correct scientific notation. I look, oops, it's not, because it has to be 1 or greater or less than 10. It's 0.4, which is not greater than 1. So I'm going to move the decimal over to the left. So I moved it to the left. So it becomes 4 times 10. And when I move it to the left, I'm going to actually subtract 1. So it's going to be to the 8th power. Okay, new example. Let's subtract 6 and 9 tenths times 10 to the negative second minus 6 times 10 to the negative third. Okay, let's go through our steps. Just the same as when we add, we're going to see if my exponents are the same. If not, I have to adjust my mantissa. So I have -2, -3, not the same. Again, I always go to the bigger one, so I'm going to adjust this -3 up to +2. So I want this to become +2, which means I'm going to add 1. So I don't touch the first scientific notation. I'm still subtracting. Notice that right now, that decimal's, I don't know how that got there, but decimal's right here. I want it to go to the right because I'm going to add 1. Okay, so if I go to the right, that becomes 0.6 times 10 to the negative second. Now we're good to subtract since the exponents are the same. So I'm going to take 6 and 9 tenths minus 0.6. And I'm just going to bring down my base of 10. And I'm going to actually subtract. And that becomes 6 and 3 tenths times 10 to the negative second. Ooh. And I got to check if it's in correct scientific notation. It's between 1 and 10. Looks great. And I know that I am done with my problem.